Okay, so we have in the past talked about distributive property, and today we're actually going to talk about the reverse of doing the distributive property, which is probably actually one of my favorite concepts as far as algebra goes. Okay, so what we have here for our notes is we actually have 4 examples, and I don't know why it says 1, 2, 4, 3, but that's what happened. So what we're going to do is I'm actually going to do one of them as an example. I'm going to encourage you that if you feel ready, you try to do the one next to it. And then if you don't feel ready, that's fine. Just continue watching the video and go along with me. Okay? But at some point you will need to be able to do this by yourself. So there's no harm in you trying to do it by yourself right away. So we know with distributive property, we usually take whatever's on the outside of the parentheses and we multiply it by both items that are inside the parentheses. Well, with reverse distributive property, we try to break down things that are written as addition or subtraction to see if they have anything in common that we can pull out, thus reverse of the distributive property. So what we're going to do first is we're going to look at 6 and 8, and I want you to think about the factors of 6 and 8. That means the numbers that we multiply to get 6 and to get 8, and think if they have any common factors. So hopefully what you're thinking about is, yeah, they do have some common factors. In fact, the common factors that they have would be 2. So for example, I can break 6 down as 2 times 3, and I can break 8 down as 2 times 4. Okay, so when I do that, what I've seen is that they actually have something in common. They have this 2 in common. Since they have that 2 in common, I'm going to write the 2 outside the parentheses. Now what's going to go inside the parentheses is everything that's left over. So I'm going to have 3 plus 4. 3 plus 4. Okay, so this means that this should be the same thing if I distribute it. So let's actually check that by multiplying. What's 2 times 3? Oh, it's 6. Plus sign. What's 2 times 4? Oh, it's 8. So you'll see that these two expressions are actually the same because I checked it and it came out the same. All right. So if you want to try the one that's right next to this problem on your own, go ahead. If you feel like you're not ready yet, that's fine. We're going to do it together. If you want to try it on your own, pause it right now. Okay, so moving on to the second problem, we're going to do the exact same thing. I want you in your head to think of what is the biggest factor that these two numbers share. So think about what numbers do we multiply together to get 12 and that we get to get 20. Is there a number that they have in common? I'm hoping that you thought of the number 4, because here we have 4 times 3 will give us 12. And if we do 4 times 5, we will get 20. So again, I'm going to look at what they have in common. They have 4 in common, so that's what I'm going to write outside the parentheses. Sorry about that. So 4 parentheses. Hopefully right now you can guess what's going to be inside the parentheses. I have 3 plus 5. 3 plus 5. And again, if I wasn't too sure about myself, I wanted to check that this was right. One thing that I can always do is distribute it back in and make sure that I get the same expression. So 4 times 3 is 12, that's correct, and 4 times 5 is 20, that's correct. So I can check just like that I actually got this correct expression here. Checked it, done. Okay. So that was the most straightforward examples we could look at, but we actually use this in a lot of different things. And since we are talking about algebra, of course, we're going to use this with variables as well. So I'm going to take a look at this first variable problem we have here, and I'm going to break down all of the multiplication so that I can really see the factors. Okay, so first I want to just look at the numbers because that's what we focused on in our last problem, and it'll be a good way for us to start looking at this problem. Now 2 I can't break down anymore. 2 is 2 times 1. I can't make it any simpler than that. But maybe I can find a 2 in this 10. And we should be able to because this is 2 times 5. Okay, now I want to break down the variables because the variables are also something that could be in common. So if I have x squared, by now we should for sure know this is x times x. Okay, if I have just x, well, that's just times x. can make this a little clearer. This is a 5, not an S. Okay, and again, I'm going to look for what they have in common and only what they have in common. I don't want to count things twice. So if I look at the numbers that they have in common, what I'm seeing is they have a 2 in common, okay? But they also share one x. And once I highlight that x, you'll see there's no more x's here, so I can't choose this x2. I can only choose one of them that they have in common. So since they have a 2 and an x the same, you're going to see that that's what I'm going to pull out here in my parentheses. 2x, parenthesis, and every single thing that's left, I'm going to put right back in. So I have 1x minus 5. So I can write the 1 in front of the x, but we should know now we don't have to. So I have x minus 5. Again, if I wanted to check that this was right, I would just have to distribute it and check what I got when I multiplied. So 2x times x is 2x squared, and 2x times a negative 5 is a negative 10x. So check, we did that one correct. Okay, if you're feeling pretty solid right now, like you feel like you can do the next one or you can try to do the next one on your own, go ahead and pause it and move on. If you're not feeling like that, then go ahead and we'll do it together. Okay, so again, I'm looking at the numbers first because that's what I'm most comfortable with. 3, I cannot break that down anymore. It's just 3 times 1. And I'm looking for 3's in 27. Hopefully we thought of, oh, that's 3 times 9. Okay, we know how to break down our x squared. This is x times x. And we know our x is just x. Okay, so again, we're going to start by looking at what is it that they have in common. They have a 3 in common. They have an x in common. So once I've done that, I can pull out my 3x. There it is. And everything that's left over is going to stay inside. So 1x plus 9. 1x plus 9. Again, I don't have to put the 1 here, but I can. 1x plus 9. And hopefully you're getting into the groove now. If we wanted to check this, we'd have to multiply by distributing. 3x times x is 3x squared. 3x times 9 is 27. So I see that these two actually work out. So we've done that one correctly. Okay, we have 4 more examples. They're going to move pretty quickly, especially these next two. So for these next two, they're very similar to what we've done just on top of this. So let's, it's a little bit different because the first number can actually be factored there, even if we don't have to. Okay, so looking at 4 and 20, trying to think of their biggest factor. I know 4 can be broken down into 2 times 2, but I actually know that 4 goes into 20, so it's better if I just leave it as 4 times 1. And now I'm going to break down this x right away, x times x, and I'm going to have 4 times 5 times x. Again, we're going to look at what do they have in common. We're going to pull that out, 4x. So what's going to come out? And what's going to be left inside of our parentheses is our 1x minus 5. So 1x minus 5. If I wanted to check if we did this correctly, I'd have to distribute. Well, 4x times 1x is 4x squared. And 4x times a negative 5 is a negative 20x. And you'll see we did do it correctly. And we're ready to move on to the next problem. Again, I really, really, really want to encourage you, if you feel like you're ready, try to do the next problem on your own. If you're not ready, then follow along. Okay? Again, I'm looking at 3x squared, take away 12x. I know that 3 goes into 12, so I'm just going to leave it as a 3 times 1. I couldn't really write it as anything else anyways. And I'm going to break down this 12x as 3 times 4 times x. And immediately I'm going to look for what they have in common. So they have a 3 in common, they have an x in common. That's what's going to be on the outside of my parentheses. It's getting pulled out of the expression. And what's going to be left inside the parentheses is our 1x take away 4. So I'm going to have 1x take away 4. If I wanted to check this, I can distribute. 3x times 1x is 3x squared. 3x times negative 4 is negative 12x. Okay, again, we can see this is correct. So it worked out for us this time too. Okay, these next two examples are a little bit more tricky, but also a little bit easier too. So these next examples, you'll see that there's already some multiplication happening in our problem, right? I have x times this expression, and I have 5 times this expression. And luckily for us, I can't break this down into factors. This is already as factored as it can get. What I can do, though, is check to see what they have in common. So I can see clearly that this x minus 3 piece is what they have in common. And I can also see clearly that what is left is the x plus 5. So what I'm going to do is I'm going to pull out this x minus 3. It's what it has in common. And I'm going to rewrite the rest in the parentheses. So this is going to become x plus 5. Okay, if you wanted to check this one, you would have to, 1, distribute this and then combine everything together. And then 2, you'd have to FOIL this out and combine everything together and make sure that the answer was the same. So I'm actually going to take the time to do that right now because I think it would be a good thing for us to practice just so we don't forget what we're doing. So I'm going to start with multiplying the top part out. So x times x is x squared. X times negative 3, negative 3x. Okay. 5 times x plus 5x. 5 times negative 3 minus 15. So we put together the items that are in the middle, and we get x squared plus 2x minus 15. Okay, so we're going to do what I'm going to do next, and I'm going to check to make sure that this expression, when I FOIL it out, actually equals the same amount. So first times first, x times x, x squared. Outside times outside gives me that plus 5x. Inside times inside, negative 3x. And negative 3 times positive 5 gives me negative 15. So you'll see the order was a little bit different. When I combine it, though, we still get x squared plus 2x take away 15. So I can see that these two answers are exactly the same. So that lets me know that I rewrote our expression correctly. This way, I did that correct. Okay, so we're going to do one more example like this, and then you're going to get straight to your group work. So looking at this example here, what I notice here is that they both have this x minus 5. So that's what's going to be pulled out of my expression, x minus 5. And my question to myself is, what stays inside the parentheses? Well, whatever is left is what stays inside the parentheses. So for us, that's x plus 4. Now, I'm not going to require that you check the ones that look like this. But any of the other problems that look pretty straightforward, like these up here, you should be checking those. Okay? If you take a look at your group work, you're going to see that you have 8 problems. And again, they very closely mirror what's happening in our notes. So if you're feeling stuck here, take a look back at this video or take a look back at your notes. Be checking your answers along the way. So what I would like you to do is do this problem, then check the video for the answer. Do the next problem, then check the video for the answer. I just want to make sure that you're practicing correctly, or else you're just wasting time. All right.